Assalamu alaikum, Bismillahirrahmanirrahim. Welcome to lecture number 13-week lecture, lecture number 25 and 26. In the previous section, we just studied some basic terminologies that affecting human person, and for the human comfort, we need to apply HVAC system. And the basic what kind of HVAC system utilizes in the offices, in commercial buildings. We have a short video about that. Now from onward we will do some more details to that system and analyze particular system one by one. In the previous video, like this, we have studied all that standards and what kind of process have been done in the HVAC system, and we also covered one detailed video of HVAC that includes all the parameters that in which we are using in the HVAC system. Okay, so let's just revise very shortly and move towards another detailed video of HVAC system. In HVAC system, we are doing heating in winter seasons, and as well as even in the summer season. We will discuss it later when we are doing heating process even in the summer season. And the cooling process, you are already learned refrigeration air conditioning cycle, in by which we are producing cooling effect. Humidifying effect, in some areas they are very dry weather like Koita, so there we will provide humidifying process by evaporating water in the incoming air or supply air. And dehumidifying process is opposite of humidifying process, like in Karachi, that is situated around the sea, so we have a very humid weather. So to remove that humidity, we need to have a dehumidifying process, and two types of dehumidifying process utilize in HVAC system. One of them is extreme cooling and then extreme heating. By this process we can remove humidity. Let's just go towards I just explain a little bit. I just cancel this video. Like you can see, yes, so you will amaze how we can produce dehumidifying effect just by cooling and extreme heating. For an example, if we need to set our design or operating point of the room or office to 23 degrees centigrade, and the more desirable relative humidity around 50%, so we can set our point towards here. This is 20, this is 25, so 23 will be between this point, or even for ease we can set 25 degrees centigrade. So let's take 25 degrees centigrade and 50% relative humidity, so the point comes over here. So to achieve that point or to achieve that humidity, let's consider normal condition of Karachi weather. Like we have a temperature, we don't have a very high temperature but very high humidity, like 35 degrees centigrade. Let's suppose we have a 35 degrees centigrade and the humidity level it's around 80% or 80%, like here. So this is 35 and 80% humidity is lie at this point. So you can see that our design point is very far from the current weather conditions. So when we are applying cooling, the graph shifts towards the left and in a straight point. You can see that is 35. So 35 degrees centigrade and 80 degrees centigrade of humidity, when it's cooled down, the line goes like this, like a 35 degree of air passing over a cooling coil, so it's get cooled down. So dry bulb temperature is also cooling. We already discussed what is dry bulb and what is wet bulb temperature. Dry bulb temperature is simple normal temperature in which the thermometer bulb is dried, and the wet bulb temperature is when the thermometer bulb is dipped with the um, water dipped cotton. Okay, so when this is 80 degrees centigrade humidity and this is 35 degrees centigrade. So when we cool down the air, the molecules of air compress, contract, come closer. As you know that when we applying heating, the molecules expand, the liquid or gas or solid expand, and contrary, if we apply cooling effect, they will contract. So the the size of the air becomes shrinking, and due to the shrinkage you can see that the humidity will also increase, because on the same size now the amount of water is increase, or have a high low capacity of evaporation. So again the graph moves like this, and uh, when the air reaches to the 100% humidity, this is 100% humidity, now the graph cannot move further left. So then what is happening after reaching the dew point? It is also called dew point, 100% humidity. The water molecules water molecules in the air, that is also in the gaseous phase, now condense to its original water in water form, in liquid form. Okay, so now the amount of water is removing from air. So the graph is moving like this till it reaches point where we are when we have a most desirable humidity. Okay, this is 50% humidity, and you can see that the amount of water is removing. This is relative humidity and this is actual absolute humidity, the amount of water in air, and the unit is like humidity ratio, that is gram water divided by gram dry air. Let's suppose at this point we have a 0.025 gram of water per gram of dry air. Okay, so now you can see that when we are moving from this point to this more desirable point, the amount of water present in the air is decreasing, and where the water is going, it is condensed into the liquid form. And you can see that in the indoor unit of the AC, the liquid the liquid is forming around the evaporator coil, and that water is removing from the room by some sort of pipe, and we are usually collecting into the water into the bottles, etc., or directly send it to the drain. You can easily see in the indoor unit. So why this condensing water coming? This is the condensing water coming. You see that the graph is moving like this. The amount of water molecule is decreasing, but the relative humidity is not decreasing. Because why it is not decreasing? Because it doesn't have a capacity to evaporate more molecule, or doesn't have a capacity to hold more water in the air, and we are cooling that air. We are cooling in that air, so the relative humidity it is not decrease, but the amount of water is removing from the air in the form of condensing water. So when it reaches the point like 15 degrees centigrade, okay, 15 degrees centigrade, so you can see that even though we require to have 23 degrees centigrade of air, but we cool down that air to 15 degrees centigrade. You see that 15 degrees centigrade, and when it reaches the 15 degrees centigrade, we then heat that air to gain again 50% humidity. Okay, Now you can see that we have to cool down air from 35 to 15 degree centigrade, then again reheat that air to 23 or more desirable point, you can say 25 or 22, whatever need to do. Even for the 23 we have to decrease temperature around 12 degrees centigrade. This is 15, we have to cool down the air to 12 degrees centigrade, then again reheat to 23 degrees centigrade. And in more pharmaceutical companies, we have a reheaters that heat the point and get the measurable quantity of humid air, relative humidity air. Like they have a standards to maintain 50% of humidity of air, 40%. So we have a accurate heater that send the air according to the parameter, like 50% relative humidity and 23 degrees centigrade. But normally in our rooms we don't see any heater in, even though an indoor unit of an AC. So how the amount of air is get reheat to 23 degrees centigrade? It is reheat by contacting the surrounding air. Like for an example, the air coming in the indoor unit of a coil cool downs to what, 12 degrees centigrade, and then when the air leaving from the indoor unit, it it, it doesn't reaches to you directly. There's some distance from indoor unit to your skin. So in between this distance, it collide with surrounding air, and surrounding air temperature is 35. So it mixes with the 35 degrees centigrade and gets reheat to 23 again, to 23 degrees centigrade. This process is works like that. But if we need to have accurate amount of humidity, and we don't have a very accurate amount of humidity of 50% in our rooms, it sometimes it gets 60, sometimes it gets 70, but we are just only maintaining the dry bulb temperature in the indoor unit by setting from the remote. If you set the temperature 23 degrees centigrade, the compressor stops the AC when the surrounding air becomes 23 degrees centigrade. When the incoming air in the indoor unit becomes 23 degrees centigrade. So you can see that to do dehumidification, we need to do some extreme cooling, then it reheat either by heaters for the more specific and accurate amount to get the more accurate amount of air parameter of humidity and temperature, and secondly by striking with the surrounding air. By mixing with the surrounding air, it gets reheat to certain point of temperature to achieve 23 degrees centigrade. Anyway, we have also have a second type of machine that makes dehumidifying effect. That is yes, second process for dehumidification effect is by desiccant wheel. This is the desiccant wheel. It is widely used in pharmaceutical companies, because in pharmaceutical companies we have to maintain accurate amount of humidity in the rooms, because high humidity makes things or tablets or whatever the mixing materials of the tablets into the undesirable conditions, or it has a expiring effects, etc. So they have very high standards of clean and dehumidified air. So in pharmaceutical companies, to have more accurate amount of humid or humid air, dehumidified air, we use desiccant wheel. The desiccant wheel is consist of silica gel material, and it has a natural capability to absorb humidity, water molecules. So in this process, the ambient air comes to passes from this filters, and it absorbs the humid air, and pass out the dehumidified air. And you can see that if the every uh, the silica gel in this partial portion have some capacity to absorb water molecules. When it consume, when it absorb 100% of its water molecules up to their capacity, it cannot hold more humidity or more amount of water molecules. So we have to continuously regenerate it. How we can regenerate it? You can see that partial lines. 50% of the air is air is passing only from the 50% of this desiccant wheel, and the remaining 50% of the desiccant wheel is regenerated. Once the air is passed from this this partial 50% portion, air water molecules absorb in this portion, and when it's fully absorbed, this wheel rotate by this drive motor. So this portion comes to this point, and then there we have a heater, and the heater from steam we can heat up the air. The hot heated air, when passes from this already 100% consumed portion, it's evaporate water molecules from this desiccant wheel, and it goes to atmospheric air from outside of the room. So it again regenerate, and when this portion regenerate again drive motor rotates this wheel towards this point. So it continuously absorbing the ambient air humidity and continuously regenerating by evaporating the water molecules from the ambient air to the from outside of the room, outside atmospheric air. So from these two process we can have a dehumidifying effect. Yes, I hope you understand by this animation and by these pictures. But when we have a regular class, I just have a class in our mechanical engineering lab where all these physical instruments and machines are available, so a student can easily see these physical machines and their working. Anyway, I just did my level best to give understanding of this type of machines, how they can remove the air from the from how they can dehumidifying air by these two processes, by extreme cooling and heating, and second process from desiccant wheel. And then we have a cleaning process. Like for the cleaning we have filters. You can see the filters in your indoor unit, but in the industrial setup we have a detailed video here we previously watched detailed video about
the basics of HVAC.
Evaporation.
This feature is critical in facilities that contain clean rooms, medical facility, energy-efficient environments, HVAC system for cleaning, engine components, and economic air operations and various.
Yes, these type of air filters. These type of air filters can be HEPA filters or not HEPA filter. They are G4 filters by simple fabrics, cotton fabrics. When the air pass from this cotton fabric, it holds the dirt particles, the pollen particles, etc. And for the more accurate clean air, we use HEPA filters, and HEPA filters use on this. Sorry.
Consists of one or more.
Yes, from this point, HEPA filters, and it can clean the air up to the 99.99%. You can see in the pharmaceutical companies. Okay. Now this portion already we have clear. We have covered in this video, in previous lecture, and ventilation. I already explain a very long time to explain ventilation, why the ventilation is needed, because we need to have uh, amount of oxygen in the room as per ASHRAE standard. You already done one numerical over it. So we can exchange air from some air we can do rotate from the inside of the room, and some air we can take from the outside atmosphere. And we also have some kind of air movement. For the air movement, normally you can also experience air movement effect of comfortability by putting on your room fan. You can feel the comfortable effect. So from the air movement, even from the air movement, you can feel the comfortable effect. So we also have some air movement inside the room. Okay, now to achieve that cooling system in the buildings, in the offices, we have a chiller. We have a machine called chiller. Not only AC. In a domestic use, we have a device for cooling purposes, AC. But in offices, in commercial buildings, the device which is used in HVAC system for the cooling process is called chillers. And we have a multiple type of chiller, like you seen in this particular picture: water-cooled chiller, air-cooled chiller. And how they work, we have some animated video. I just explained from this animated video how they are working in any building. Like first we have a water-cooled chiller. Water-cooled chiller normally situated at the bottom of the building, like here, or it can be placed over the roof of the building, but normally they are in the basement of the building. In the water-cooled chiller, we cannot directly cool down the air from the refrigeration process. Like in our room, we have in the evaporator coil, we have a refrigerant gas, and it directly contact or transferring cooling towards the surrounding or room air. But in offices building, we cannot do directly by this process. We have some different process. We cool down the water, and then chilled water goes towards the air handling unit. And this chilled water, the temperature of chilled water is around 4 to 7 degrees centigrade. So this refrigeration, the refrigeration unit is cooled down the water up to the 4 degrees centigrade, and this 4 degrees centigrade moves toward the air handling unit. And that in the air handling unit, the water gets cooled when it's contacting with the 4 degree chilled water. And during this process, now the water gets heated, because it does not change its form. It goes in the liquid form, and also goes out from the in the liquid form. So it just only decreasing its own it's increasing its own temperature and decreasing the incoming air. So 4 degrees centigrade of chill water goes there, and it's cooled down the air up to 12 to 15 degrees centigrade, all as you already seen in the psychrometric chart. And the water gets heated from 4 to 12 degrees centigrade. 12, sometime it's 8 degrees centigrade, or we have a delta of 5 degrees centigrade. Like if the chill water is going around 4 degrees centigrade, it returns to 10 degrees centigrade. And if the chill water goes like 7 degrees centigrade, it's returned 12 degrees centigrade. So we have a delta of 5 to 4 degrees centigrade. So on the return, the water gets heated and returned from 12 to 10 degrees centigrade, and again refrigerator cool down it to 4 degrees centigrade. So the water is circulating, and the air is cooling by the chilled water. And the chilled water do not directly physically, it just transfer the cooling and get heated itself. You see that this is the air handling unit. Now you can see that in particular picture, we have, yes, this is the chiller, this is basically chiller, this is air handling unit, and this is what? Cooling tower. What? Cooling tower. In You can see that cooling tower in Millennium Mall, in the roof of the Millennium Wall, or Lucky Mall, on many different vast structure buildings. Now what is the need of the cooling water here? Cooling tower, sorry. You see that the outdoor unit of AC is directly rejecting heat in atmospheric air. So, or you already study the heat transfer. You see that the heat transfer rate of the air is lower than water. Water have high heat transfer coefficient, H value. So in this portion, the condenser of the refrigerator or a chiller is cooling by water. Similarly, the evaporator is transferring cooling in the water. So condenser is also transferring heating in the water, because water have more capacity of absorbing. Okay, so the water absorb heat from the condenser, and it goes towards the top of the building, and it showers. The water is showering, and by the showering, the water now gets cooled from the atmospheric air. Like the temperature of this condenser water is around 70 degrees centigrade or 50 degrees centigrade. When it is sprinkling from the top of the cooling tower, it spreads, and due to the evaporation process, you see the evaporation process, you split the water in the floor. So, after some time, water evaporated, and due to the evaporation, you have a cooling effect. So similarly, same process is working over here. The water is sprinkling from the cooling tower. It's the air also, there also a fan, and the water comes from the bottom and leaves from the top. So it's contacting with the water, and by this contacting, some amount of water is evaporated in the air, and the water gets cooled down, and that cooled down water again goes, like temperature of this water becomes 35 to maximum 40 degree or 35 degree centigrade. When this 35 or 30 degree centigrade again goes to the condenser, it cools down the condenser. So in water-cooled chiller, the cooling is also transferring into the water, and that water transferring cooling into the conditioned air. Similarly, the condenser is cooled down by the water. Water is absorbing heat and rejecting from towards the atmospheric air. This is water-cooled chiller. We will further discuss it later when we see the loop system. You can see that building. This is the video. These are the cooling towers. You see that